Good afternoon to everybody. Today, I'm very delighted to have my very dear friend, Dr. Zarar Fakir Youssef from NEC Laboratories Europe in Germany, to give us a talk on network function virtualization as part of this Mosaic Lab invited talk series. So his talk title, actually, as you can see on the slides, it's going to be a journey around what has been happening in NFV in the context of 5G and maybe the road ahead towards beyond 5G or even 6G. So let me introduce Dr. Fakir Zarar. Zarar is a senior researcher at NEC Labs Europe in Heidelberg, Germany. He has over 20 years of experience in the area of telecommunication and data networks. His current research focus is on network function virtualization, software-defined networking, and related technologies, and that's in the context of 5G and beyond network architecture and operations. Currently, he's serving as the chairman of the solution working group in ETSI NFV, and he is also a rapporteur of multiple work items. He was awarded NEC's Standardization Fresh Player Award in 2015 for outstanding work in ETSI NFV. Dr. Youssef has extensive experience in the design, development, modeling, and simulation and prototyping of novel protocols, algorithms, and system methods for optimizing network performance. He has 9 granted patents, and his research work has been published in different international journals, conferences, and book chapters. So Zarar, the floor is yours.
Thank you very much. Thank you, Tariq, for the invitation first, and also for the kind introduction. So without much ado, so what is the objective of my talk? So the objective, basically, I had a discussion with Tariq, and then the objective is basically to take you on the journey and acquaint you with the developments that is taking place in the ETSI NFV community in the context of standardization of NFV technology. And then based upon that, scope the relevant innovations dealing with the challenges lying on the road ahead, that is beyond 5G, which is 6G and beyond. So I would not like to go into 5G, but of course we're all aware that previously, as the internet transformed towards the internet of everything, there was more and more reliance of verticals like automotive sector, logistics sector, hospitals, cities, government sectors, to basically to have high reliance on your mobile networks. And of course, with this high device penetration of smartphones, which required a lot of, which generated a lot of smart data, you basically required to handle the smart data in a smart way. And it so happened that the previous Gs, like, up to 4G, they had reached the, let's say, the peak of their capabilities to be able to handle such diverse service requirements that is demanded of a mobile network. So in that case, the answer came in the form of your virtualization technology, and basically 5G was born. And 5G was basically was a paradigm shift from the traditional networking technology, which was based upon TCP/IP and its management. And basically 5G brought with it a change, a complete paradigm shift of changing the way we develop networks, and based upon your virtualization technology. And based upon that, of course, as we progress, this was done to enhance the revenue streams of the operators, improve the CapEx, OpEx, make your networks automated, be able to roll out novel services, and not in the matter of days, but in the matter of hours or even minutes. And of course, to ensure that there is no vendor lock-in. One very interesting point would be that before 5G, your previous generations were driven by the user, by the customers, by the data demand. But I would say 5G and beyond, especially 5G and NFV, this is something that is being driven mainly by the operators, because they have to really find a new way of how to design your network infrastructures. So as you're all aware, up till now, because 5G is based upon 3 distinguishing features. One is your providing enhanced mobile broadband communication services, supporting massive machine type communication services, and providing ultra reliable low latency communication services. Now, when these features, when they have to be translated into your technology, they have very stringent requirements. And basically on the screen, you can see a set of requirements in terms of reliability, low latency, and connectivity density, and etc., and even energy, etc. Now, the thing would be that when you talk about when we started developing 5G, and now right now, let's say in 2020, the first rollout of 5G started happening. But then again, as we started developing on 5G, new use cases and business innovations and business use cases came into existence, which were previously not envisaged with the previous Gs, right? And that basically also showed us that the various demands and the gaps and the challenges and the innovation possibilities that 5G laid bare that could not be perceived or before in the previous Gs. So there were many new use cases and business models that came into existence. And I would say that these use cases fall under three different categories of your use cases. One is your holographic communication services. The other category of use cases come under the tactile and haptic internet communication services. And the third one is under the network and computing convergence, right? So now, basically, these were something that, like I said, became aware as we started working and developing 5G. And of course, this showed and laid bare to us that the further challenges that lay ahead, and the answer now is in the form of 6G. Usually, some people call it 5G++, but now the more prominent term is 6G. And if you look at this figure that I took from the 6G flagship project from NTT Docomo, if you look at it, the requirements are much more stringent as what we had envisaged in your 5G. For example, in 5G, the reliability was based upon upon 5 nines. But here, basically, your reliability requirement is 7 nines. And you're talking about 1 terabit per second peak data rates. So this basically makes a much more higher demand on how you design your network and how you manage them. So based upon these requirements, I basically was able to derive 4 main technology themes. Okay, so those, if you put these 4 technology themes in one sentence, it would basically be stated something as the autonomous management of microservices in a multi-site deployment environment where your core and your edge networks are converged. So it is in the context of these 4 technology themes that I would be basically talking about what we are in ETSI NFV doing to enhance or extend our management framework, the ETSI NFV-MANO framework, to be able to meet the requirements of 5G and beyond, right? And also to basically familiarize you the activity that is happening in ETSI NFV, which is very much in line with the current developments and also the requirements of the future. So when you talk about the challenges, so basically I kind of, we have this Internet of Everything or Internet of Things, and basically a network that should be able to handle this or manage this, the diverse requirements of the Internet of Everything are basically, it should be cost efficient, it should be performant, there should be flexible and agile management, it should be programmable. But so these challenges that you see in the blue, they were something that was basically for the 5G. But with 6G, right, we are now looking at some further challenges, which is about zero-touch management, portability, a cognitive network, autonomous management, and it should be green. And basically to address those things, we have the NFV SDN as the technology enablers. And like I said earlier, that these are the disruptive networking paradigms, as disruptive as IP was at its own time. And when you are going to bring this NFV and SDN technology paradigm into your network, it is going to have much deeper and far-reaching implications on how you design and architect your RAN, edge, and core network systems. So basically, to quickly give you an overview of what NFV is. So NFV is basically a technology enabler which decouples your network hardware from its network functions, right? So, for example, in this figure, you can clearly see that these on your right side, sorry, on the left side, you have these legacy traditional networking equipment, routers, switches, load balancers, media servers, etc. But now, in using this NFV technology, you can basically instantiate and deploy these network functions as basically virtual machines. And that would imply that you can basically group these different network functions and realize them in virtual machines on a COTS server. So although this is a beautiful and amazing technology, because it takes care of a lot of problems that we were having in a traditional network management, but again, it also give rise to new challenges, new management challenges. And for that, basically, we have this management framework, which we call a MANO framework. MANO is basically short for management and orchestration. So this is what the ETSI NFV, which started in 2012, 2013, that is where they came up with. This figure that you see over here, this is basically the main ETSI NFV prescribes standard NFV-MANO framework, okay? And if you look at it, there are basically three functional blocks. The top level block is called the NFV orchestrator. Then we have this VNF manager, and then we have this virtualized infrastructure manager. And what the NFVO does is that it is able to perform the lifecycle management of and performs the resource orchestration and service orchestration, and a combination of them. Then for the VNF manager, it is basically designed to manage the lifecycle of your individual VNFs or virtualized network functions. And then we have this VIM, which basically manages the use of NFVI resources. To give you just some sort of an idea, so when you look at your OpenStack, so an OpenStack is an example of your VIM, right? So the challenge was that in your traditional networking management domains, your typical network manager would perform FCAPS management, fault management, configuration management, accounting, performance management, and security management. That's called FCAPS. But with the NFV, now this MANO framework not only does it need to perform this FCAPS management, but in addition to FCAPS, it has to perform the lifecycle management of your VNFs and network services. Okay, so what is lifecycle management? That basically means the automated deployment, management, modification, scaling, migrating, updating of your VNF instances. Okay. And this is the feature that brings the enhanced flexibility, management flexibility, and agility to your networking domains. Just one more thing that I would like to just for reference. So VNFs are virtualized network functions, and network services basically are composed of a single or multiple VNFs which are interlinked with each other over virtual links to give you a complete network service. For example, EPC, right, an evolved packet core. If you implement or deploy an EPC as a virtualized network function, then this EPC will be composed of multiple small virtual network function components which are interlinked with via virtual links to give you a complete end-to-end EPC service. So this was basically the object, the management framework that ETSI NFV has and is working on. And you can see over here that they are linked by different reference points. And in the next slide, will basically give you a much better idea. So in this, you can see that for different reference points between the different functional blocks, ETSI NFV up until now have defined different interfaces, right? So for example, if you take an example of your reference point between the NFVO and the VNF manager, you will see basically that there are different interfaces which are available for the VNF packet management, lifecycle operation granting interface, lifecycle management interface, performance management interface, fault management, policy management, and VNF snapshot package management interfaces. So, and each interface is then basically manifested in a set of operations, okay, input operations and output operations. So then in this slide basically can give you a very good overview of the different interfaces that we have so far defined over these reference points. And let me also assure you and notify you that these interfaces, they keep on getting changed, and new interfaces may keep on getting added as newer requirements come into place. And I would also like to mention this another new interface or new reference point called the OR reference point, which is basically for interconnecting multiple NFVSOs in different domains. This in loosely you can say it's also a federation interface. So this is basically to interconnect different NFV-MANO domains with each other. And I will be talking about this also in the context of multi-site connectivity services. Now, what is happening in the ETSI NFV community? So like in any standards organization, we are every year, we are basically publishing our specifications, and we're going through different releases. So previously we started with release 1, and over there it was to set this NFV architecture and basically define the reference points and the bare minimum interfaces. And this was what you saw earlier, this figure of the NFV-MANO framework. That was the outcome of your release 1. And basically in release 2, we started focusing more on the interoperability of solutions based on the NFV architecture, detailing the specification of the VNF package, the VNF descriptors, the network service descriptors, and also basically internal and external NFV-MANO interfaces. Then came release 3, and release 3 basically came with enhancing the feature set and the capabilities of the existing MANO system, right? And there were many features were proposed, and they were accepted, and work started on specifying those features. Again, to enhance the capabilities and the functional output of your ETSI NFV-MANO system. And some of the features, just to give you an idea, it would be defining a detailed policy framework, the VNF snapshot management, the management of the NFV-MANO system itself, right? Because if you have a management system that is managing your network, you basically also need to make sure that your MANO system is also being managed appropriately to give you a much reliable and stable network services. And of course, the topic of cloud native was also came into release 3. Then came release 4, and this basically focused on the orchestration, cloudification, and simplification of network deployment and operations. And some of the features that were defined for release 4 were container-based deployments, further 5G support, service-based architectural concept, and generic OM functions, and many, many more. Okay, so right now we are in a stage where we are finishing some of the release 3 features, and we have started working on release 4, and hopefully by this year end or by the middle of next year we will be done with release 4. And just 2 weeks ago we have invited proposals for release 5 features. So if you think that you have an idea or a topic or a technology theme that is not being covered so far but you think is important for the further development of the NFV-MANO system, so please contact the ETSI NFV community. We are very open, and we would really like to hear from you. So if you think that there is some new feature that is not mentioned over here and that is important for going beyond 5G, so this is the time. So again, it is a call for proposal has been made, and this is the current state that we are in right now. So to give you another idea or to give you another picture, so this is what the ETSI NFV release 4 feature palette looks like, right? So these are the features from the past releases, and the blue one are the releases which are carried over from release 3, because some of the features could not be completed in release 3. For example, your cloud native VNFs and container infrastructure management. So their development has now gone into release 4 as well. And of course, these are some of the new features. For example, multi-tenancy, VNF generic OEM functions, NFV enhancement for 5G, also MEC NFV convergence, etc. So what I did is that if I have basically circled 4 feature sets. One is your multi-site connectivity. The other is cloud native VNFs and container infrastructure management. The other one is automation and autonomous network management, and your network connectivity and integration and operationalization for NFV. Because these are the four features which relate to the 4 technology themes that I just mentioned, which I said were more relevant for 6G. So let's talk about the first on the management of cloud native NFV workloads, and just to familiarize you that what we are doing in the ETSI NFV community. Now, when we talk about your when you talk about your cloud native VNFs, right? So we're talking about a VNF which follows the cloud native design principles, which simply means that you have to decompose a network function into several small independent components, which are also called microservices. Okay, so microservices are then deployed as containerized workloads. So basically, there are 2 ways of deploying your virtualized network functions. One is basically either in a VM or basically as in a container. So both have got their own pros and cons. But again, but now because of certain advantages that your cloud native design principle or microservices have, this is gaining more and more traction. So although it brings in a lot of performance dividends, this microservice architecture, it brings in a lot of performance dividends, but along with it comes a lot of management challenges, right, which were not visible or apparent before. So basically, once what happens is once you're able to decompose the VNF into different microservices, so you are able to basically group those microservices as and each microservices can be a small VNF, right? So you can have VNFs which are categorized giving you common services, meaning a VNF that is providing you services which are common to multiple other VNFs. Or there could be VNFs which are providing you with dedicated services, which are only relied upon by a few VNFs and not by everyone. For example, an example of a common service VNF or a VNF providing common services would be, let's say, some VNF providing with some monitoring or some analysis function, which is a need for basically all the VNFs, right? And a dedicated VNF services could be some sort of a, let's say, a particular gateway function, right? So again, what happens is that you're in the VNF common services, so you have all those common service VNFs, they are always enabled, always instantiated, but the VNFs which are provided dedicated services, they can be instantiated on demand. So that again basically gives you further advantages of how to efficiently use your resources, because the problem is, or the challenge is, that your resources are finite. Okay, now how to use them in an optimal fashion? So that is why that is the advantages that comes with decomposing your VNFs into microservices. That you are able to play at an atomic level of what network functions to deploy and instantiate when and where. And when you have been able to decompose them, you have also improved the reliability of your whole networks. Because now you can, for example, in this figure over here on the right side, you can see that you have multiple instances of the same VNF, right, as backups. You can basically have, or as a redundancy. This can basically be an N plus K redundancy, which can be deployed either in the same, or you can be deployed in different NFVI POPs or different NFVI sites, right? So, and of course, you need to basically need to have a load balancer and also a failover agent that is able to distribute the load across these different fallback instances, and also distribute the load between different redundant instances. So this is basically one of the advantages. But again, if you can see from the figure that the challenges become very obvious, that when you are deploying your redundant VNF or microservices across multiple sites, then you are also dealing with the problem of the transport network or the underlying network. and again, everything has to be done in a performant manner, because that means that every services have to be provided their required quality of services. So in this context, the ETSI NFV document IFA 29, which is now published, it studies the potential impact on the NFV architecture, providing platform as a service type capabilities and supporting VNFs which follow the cloud native design principles, in particular the utilization of container technologies. In this context, it defines the following three key elements. One is this container infrastructure services, which offers the execution environment for the container cluster where the microservices can run. And typically, they deploy OS containers images in a VM or on a bare metal, and you will see in the next slides. And it also provides the ability for consumer VNFs to execute any capable software inside the containers. And it runs in the parent virtualization containers using the infrastructure resources of the NFVI, and it is managed by the VIM. The second important element that is being introduced by this IFA 29 is this container infrastructure service management, right? Which is basically responsible for the deployment, monitoring, and the lifecycle management of containerized workloads or microservices which are deployed in the OS containers, right? And it is also responsible for the parser and interpretation of the descriptor files and configuration files for the containerized microservices, right? And the CISM, the container infrastructure service management, is composed of three main functions, which is the container runtime management, the container storage management, and the container network management. Because all those microservices, all those containers, they have to be then also networked, right? And they also may have requirements on some storage mechanisms. And then we have this container image registry, which is responsible for storing and maintaining information of the OS container software images, from where you can create more OS containers. And on these OS containers, then you can basically deploy your microservices. Now, so this IFA 29 is a very detailed report, and I would encourage all of you to go and take a look at that. And it's written in a very, very concise manner. And then as an output of this report, we have a group specification or normative specification, which is called IFA 40. And this IFA 40 specification document specifies the requirements on the list of services which is to be provided by the CISM and the CIR, and on the management services interfaces to expose these services to the other NFV-MANO functional entities or NFV-MANO functional blocks. So the idea is this. The idea is that we have the NFV-MANO. Traditionally, the NFV-MANO system was designed keeping a VM-based workload in mind. But now, as 5G was being developed and 6G, now we're talking about 6G, suddenly we've realized that the microservices or decomposition of your VNF into microservices and the instantiation of the microservices over the containers is basically giving you certain advantages, certain performance advantages, right? So that would mean that your NFV-MANO system has to basically be adapted to be also able to manage the containerized workloads alongside the virtual machine workloads. And this is the challenge, right? And of course, in parallel, we are also having these open source projects like Kubernetes and OpenStack, which are an example of your practical systems for the management of containers and virtual machines. So having said that, to give you a broad conceptual overview, so your CISM is supposed to manage this thing called this managed container infrastructure object, right? And an MCIO is nothing but you can think of it as an OS container, right? And just deploy it as an OS container. And an example of MCIO if you're familiar with Kubernetes, the examples could be pods and services, deployments, replica states, stateful sets, etc. Right? So basically, MCIO is the term because every standard organization is always big on jargons. So basically, this is the managed object that is being managed by the CISM, which I introduced a while back. And then, of course, every MCIO or every object, the container object, has to be configured. It has to be deployed. It has to be instantiated. So for that, we need to have a descriptor file. And that descriptor file is basically packaged in a MCIOP. And it is basically a hierarchical aggregation of information object for the OS container management and orchestration. And an example could be your Helm charts in the Kubernetes or your heat orchestration templates in the OpenStack. And this figure kind of gives you a very good idea that if you map these concepts to the NFV-MANO information model, so the VNF component and the connection point, basically they map, or these are your MCIOs, these are your managed objects, right? And the VNFC relates to the Kubernetes pods in the world of Kubernetes, and these pods basically then can have 1 and 2 n containers in each pod. Similarly, the VNF descriptor is a descriptor file which is used for managing for describing the resources and orchestration requirements of a VNF, and they are further specified by using VDUs and connection point descriptors, and the MCIOP specification maps to the VDU and CPD, right? And like I said earlier, that the VNFD maps to the Helm chart which is used in the Kubernetes. Now, there are different deployment options of how can you deploy the MCIO. So IFA 29 specified 4 deployment options. In one deployment option, they've said that, okay, that the container-based NFV microservices can be deployed within the VNF, right? So over here, we have the NFVI, right? And the NFVI, we have the virtual machines, and basically each virtual machine can deploy a single VNF component, and that VNF component has a container infrastructure services instance, on top of which we can have these containers, the OS containers, and then you can implement your VNFs or network functions on those respective containers, right? And if you see over here that the complete VNF has got multiple VNF components, and each VNF component has its own environment, which is deployed in a VM, and in that we have deployed our MCIOs or let's say our containers, okay? And each container is then configured with a specific type of a microservice. Another deployment is that your VNF component is in a container, is deployed on a bare metal, right? And this is, I would say, also a very much is an option which is favored by many operators because it has some certain advantages as well, right? Because it doesn't have the overhead of VMs, because over here you're deploying containers within a VM, but over here you have this CIS instances on the bare metal, and then on those you have the containers. And then on top of those containers, you can have your VNF components or microservices. Then the third deployment option is that the VNFC is deployed in a container in a virtual machine. Again, your virtual machines are on the NFVIs, right? And each virtual machine will have a single instance of your CIS instance. And on each CIS instance, you can run multiple containers, right? And each container you can deploy a single VNF component, right? Or you can basically group the VNFCs across group of containers, which is an option which is given over here, that now you can have a VNF components which are basically deployed in or spread across multiple containers within the NFVI. So each deployment option, like I said, has its own pros and cons. But again, I would say these are all the possibilities that you can have of how to deploy your microservices in or how to deploy your containerized workloads. Then now when you say that, okay, so the CISM, the Container Infrastructure Service Manager, is the management module that is used for the life cycle management of your containerized workloads or your microservices, right? Now the question is, how would the CISM map to your traditional NFV-MANO? So in this case, the IFA 29 document specification gives us 4 different options of how a CISM can be mapped to the NFV-MANO framework. So one option is that basically your CISM functions are embedded within the virtual infrastructure manager as seen over here. And if you see over here that the CISM has got the MCIO management function and also the container specific virtual resource management functions, right? So the whole CISM can be mapped into the VM, or second option could be that you can distribute the CISM functions within the VNF manager and the virtual infrastructure manager, where over here you can see that the MCIO management is now part of the VNF manager and the container specific VR management is part of the VIM. Now, I would say my personal preference would be this option. Again, this is not my company's view, but it is my personal view that this is a much better distribution, because you have been able to group the MCIO management with the VNF manager, which is a natural place where it should be. And another option could be that the CISM is implemented as a standalone function block. Okay. Now, in this case, you have a CISM interfacing with the traditional VNF manager and the VIM. And the advantage of this is that you can basically plug in your external container infrastructure service managers like Kubernetes with your existing MANO system, right? Or another option could be that you have the CISM only, which is managing the VMs and the containers. You don't have the VIM or the VNF manager, but you only interface the CSM with the NFVO, and you do it for all purposes. So then, of course, when we talk about the management of your containerized workloads, we're talking about the autonomous management of those, because now when you have now implemented your network functions as microservices, it brings in a lot of management burden, right? And that which is not humanly possible. So what is not humanly possible? We come in towards artificial intelligence, okay, towards autonomous management. So for that, right now, what is happening is that the ETSI, so the current ETSI NFV system prescribes an automated management of NFV resources via a policy management interface. That means it prescribes rule-based scaling and rule-based auto-healing mechanism. This is a very limited scope, and the rules, when you talk about rule-based management, so of course your management effectiveness is limited to the rules that you have specified. So this is very, very much limited, but this is how we're doing it right now. Okay, so currently in the ETSI NFV community, we are exploring how to make the or enhance the capabilities of your NFV-MANO system towards providing you autonomous management. For that, there is a document called IFA 41, and IFA 41 is right now work in progress. It is a report, and it is basically taking input from different multiple standard organizations like 3GPP SA5, ETSI Zero Touch Systems Management, ETSI ENI, TM Forum, ITUT, and is taking inputs from them and trying to analyze how we can improve the autonomous management capabilities, or how we can bring in the autonomous management capabilities in the ETSI MANO. And of course, the scope of this investigation is on intent-driven management services, management data analytics services, zero-touch end-to-end MANO of network slices, etc. So in this case, of course, we're looking at this closed-loop automation, or CLA, in the context of NFV. And in this case, up until now, 3 use cases have been specified. One is basically on the use of management data analytics, assisted management, which is to deal with this network service alarm incident, network service health, and network service resource utilization analysis. The other one is on the autonomous container infrastructure management, which is to deal with this auto scaling of MCIOs and the auto repairing and auto upgrading of CIS cluster nodes, right? And the third use case is on the intent-based network service management, on how to basically to enable intent-based network service instantiation, scaling, and termination, whereas the intent is provided by an external system like the OSS BSS, which is to be fulfilled by the NFV-MANO. So basically, so if you look at this, a typical closed loop automation, closed loop automation system. So of course it has a monitoring agent, then it has an analysis agent, right? And which is also called an MDA, right? It is called management data analytics, which is supposed to analyze the data that is being monitored and collected by this monitoring agent, right? And this is where your AI and machine learning algorithms come into being. And then whatever analysis is sent to the decision engine, and the decision engine is then prescribes operations which are executed, right? And it goes to the management entity of either NFVSO, or NFVO, or VNF manager, or VIM, or even a CISM, right? And then of course, so this is a complete a continuous running closed loop automation, and this is what we are also studying right now in the ETSI NFV, because automation is one of the key enablers for your 6G networks. And for the architectural impact, basically we have two options: either to have this intent management integrated in the NFVO, or we have the intent management integrated as a new function block, right? So because, and each one has its own pros and cons. For example, if we are able to have the intent manager as part of the NFVO, then we don't need to have any new reference point. But if we have it as an external system, we need to define new reference point, new interfaces, right, and new operations. So which will basically make your standard activities a bit more prolonged, a bit more complex. However, this option allows the NFV-MANO system to interface with external intent management systems provided by third-party providers. This has a certain advantage. Then we go to this next topic of multi-site service deployments and connectivity for low latency services, right? Now, when we have these microservices deployed across multiple sites, now the thing would be how to connect them together. So now we're talking about connectivity of your network services. So in this figure, you can see here that you have a network service composed of, let's say, 2 VNFs, and one is in one NFVI POP, and the other one is another NFVI POP, which are in 2 different geographical locations interconnected over the WAN. But from the perspective of your NFV-MANO system, this is a single network service, right? And it will be treating this as a single network service. For that, we've got 3 specifications: IFA 22, which is a report on the management and connectivity for multi-site services, which provides recommendations derived from an analysis of 13 use cases. Then we have another specification called IFA 32, which is a normative specification, where we specified the multi-site connectivity services management interface, performance management interface, fault management interface, and capacity management interface for enabling and managing the multi-site connectivity services, right? And then we have this IFA 28, which is a report on the architecture options to support multiple administrative domains, how to then orchestrate the different network services in different domains, right? So having said that, this has its own research challenges. For example, if you look at the orchestration challenges in a multi-domain environment, there are 3 options. One option is that basically you have your orchestration domain. A single orchestration domain is handling multiple infrastructure domains within a single data center. Okay, so in this case, the problem is that a single orchestration domain will result in a single point of failure, and moreover, it will have a high KPI monitoring load, and then resulting in MANO decision delays. Now, in option number 2, you have a single orchestration domain which is handling or managing multiple infrastructure domains in different sites. So it has the same problems as in option number 1. On top of that, we have to deal with problems and delays in the WAN, which is supposed to interconnect these different domains together. And the third option is the one that has been adopted by the NFV-MANO, by the ETSI NFV community, and it is basically to have each domain have its own orchestration domain and infrastructure domain. If we have one data center, that data center will have its own orchestration domain and its own infrastructure domain. and these multiple domains are interconnected via the NFV orchestrators over the reference point, which we call the OR reference point. To give you an example of this, so there are certain, now when you deploy your network services in a multi-domain environment, so there are certain challenges, right? And those challenges is based upon basically, especially due to the mobility of the vehicles, right? Or mobility use case scenarios. Now over here, you have to perform orchestration not only at the vertical level, but also at the horizontal level, meaning that not only that you have to have orchestration of the RAN resources, of the edge cloud, and of the core cloud, right? And not only that, then you also have to interconnect the different core clouds or different domains with each other. So this three-dimensional orchestration challenges also needs to be addressed, and this is also what we're doing. And basically the answer lies in the convergence of your NFV with the mobile edge computing or MEC. And this is basically a very nice architectural figure, which is showing you the enhancement support for MEC and NFV deployments. And this figure is a reference architecture variant for MEC and NFV from this document, MEC 003 specification. So right now, ETSI NFV is also defining extensions on existing interfaces across multiple work items to specify how ETSI MEC can be deployed in an NFV environment for the lifecycle management of mobile edge computing applications, and how to reuse the existing ETSI NFV-MANO components like the NFVO, the VIM, and the VNF manager to manage the lifecycle management of your MEC applications, right? So over here, you can see that you can see this NFVO and the VNF manager and the VIM, which are now interfaced with the different MEC infrastructure components. And to give you a practical use case, this is an architectural framework of a project that I'm working with called 5G Carbon. And over there, we are basically developing an orchestrated platform for cooperative, connected, automated mobility scenario, right? Which is called CCAM. So over here, what we've done is that we've taken these MEC standards, the NFV standards, and we have used them, leveraged them, and also extended them to basically create a CCAM platform, which is used for handling the automated use cases, automotive use cases in a multi-domain environment where you have these different data centers, NFV data centers in different domains and in different countries, right? And if you see over here, we have this NFV service orchestrator, which is based upon the NFVO with a global scope. And then we have an NFVO in the local domain, which is again based upon the NFVO on a local scope. We take the ETSI NFV standards on the OR reference point, extend it to basically enable the orchestration between different domains, and also between the domains at the edge sites. And the different CCAM services are realized, designed, and deployed as cloud native applications, which we refer to as MCIOs, right? And of course, we have also developed this edge controller, which is like a CISM, and we're following those standards. So this is basically kind of an example of how those standards are being used and leveraged in existing projects. So with this, there is so much to talk about, so much to discuss and explain, but unfortunately, time is the villain. And with that, I would conclude my presentation, and I would welcome questions and comments.